Okay, today's problem is that given a binary search tree, we are supposed to basically give back a Boolean value indicating whether it's valid or not. So as you guys can see, this is a valid tree because this is a valid binary search tree because every node that's a parent, all the nodes to the left have a lesser value than that, and all of the nodes to the right have a greater value. So that's the requirement basically. For 8, 10 is to the right, it has a greater value, and 6 is to the left, it has a lesser value. Um, so the strategy that I want to take is basically with every, starting at the root, starting at the root, I will pass a range. And at that level, the node's value will get compared to the range. So I'll put all the ranges in right now. Oh. So for this one, for the root, since we don't know the value of the root, I decided to put the range as -infinity to infinity. You can think of the range as a lower and upper bound. As we move to the left, the way the algorithm works is as we move to the left, we have to update the upper bounds to the parent node's value. So for example, 5 will be the new upper bound here. And then here, 2 will be the new upper bound. And then here, 8 will be the new upper bound. Okay. But I'll hang on to this one. I'm not going to do this one now. I'll first do this one. So here, when we go to the right, the rule is opposite. We update the parent node's value as the lower bound now. So the lower bound now is 5, and the upper bound is still infinity. And here, we still follow the rule. We got to change the upper bound here. And for this one, and then just like I said before, all those numbers will be compared. So 10 will be compared, that it will be checked against these two numbers to make sure it's within range. If not, then the algorithm will send a false value, and that false value will go up recursively all the way until the root returns a false, which means then that the binary search tree is not a valid binary search tree. We're also, for the first time, we're going to be using objects. So we're going to use a node object, and then also a solution object, or maybe a checker or tree validator object. So basically, I will update you guys on the next video for the solution in Python again. Thanks.